In the previous video, we mainly focused on the loops and the for loop construct in particular. We talked about iterables and how they can be used to solve various iterative problems without writing an explicit loop construct. And we also talked about the technique of comprehension, which can be applied to lists, sets, and dictionaries. There are also a lot of things about loops that we did not talk about, such as the for-else construct, the while loop, the break and continue statements, the generators, and so on. And we will leave those topics to later videos. In this video, we will focus on the if statement. So we're gonna talk about if statement, right? Programming often involves examining a set of conditions and then decide which action to take based on those conditions. So one of the most important tasks in writing a Python program is to write conditional tests correctly, and then use the if statement or other kind of branching constructs to pick the correct execution path. And at the heart of any if statement is an expression that can be evaluated to a Boolean, which is either true or false, but not both. And this expression is called a conditional test. So we will still use the complex number example that we used in the previous video. So let's create a list of complex numbers. That's a list of complex numbers. And now we will write a for loop to iterate through all those complex numbers. And when we come to the element 9 plus 12j, we will compute and print out its absolute value. And for every other value, for every other complex number, for every other element inside of this list, we will not take any actions, right? So let's if c So if we pay attention to the syntax here, the colon after the if statement, this is the if statement, and the colon behind it, and also the indentation. You have indentation of the block of code that's below the if statement. Those two things are both essential. They are essential in terms of the syntax, right? If you don't do these kind of things, the Python will either report an error or just give you the incorrect behavior, right? The expression following the if, following the if keyword, and also in front of the colon, is the conditional test. This part is the conditional test that we talked about, right? And the simplest conditional test checks whether the value of a variable, in our case it's the value that's inside of the variable c here, is equal to the value of interest. And the value of interest is this given by this particular complex constant here. And so we are going to start with checking for equality. Checking for equality. That's sort of the simplest case for conditional test, right? And the double equal sign here, this thing here, is a so-called equality operator, which takes two inputs and returns a Boolean. So one of the input is here, that's the variable, and then the other input is here, that's the complex constant or literal, right? So if the value of the input on the left side is identical to the value of the input on the right side, then this equality operator is going to return true. Otherwise, it's going to return false. And if the conditional test evaluates to true, the block of code belongs to this if statement is going to be executed. Otherwise, Python will just ignore this code block that belongs to the if statement. So if you had some experiences with other programming languages, such as C, C++, or Java, you probably already know that this equality operator, this thing here, with double equal sign, is actually an entirely different thing from the assignment operator with just one equal sign. So here we have an assignment operator that has just a one equal sign, right? But here it's actually two equal signs right next to each other, with no space between. Right? And these two things are entirely different. It means complete different thing. This is the equality operator that takes two inputs and returns a Boolean. But this is an assignment operator that's going to assign the right-hand side to the container on the left-hand side. Right? They actually mean completely different things, so you cannot actually confuse them. But if you are a new programmer, it is actually very easy to make a mistake here because in mathematics, one equal sign, this thing, one equal sign represents equality. But in Python, it's going to give you a syntax error if you just use one equal sign. It's going to give you invalid syntax. So in computer language, equality, or in Python language, the equality actually is two equal signs next to each other. That's the equality operator. And you need to pay special attention to that because in Python it's going to give you a syntax error, right? So that's a good thing about Python because it can catch this kind of error for you. But in other languages, such as C or C++ or Java, you won't really get a syntax error. The compiler or the interpreter will not actually sort of stop the code or report the error. The code will keep executing, but with incorrect behavior. And this kind of error is extremely time-consuming to track down. In Python, there is also another operator for checking equality, which is the is operator. So we can modify this piece of code to use the is operator. So let me just copy and paste this part of the code, but change the equality operator to something that's called is. It's also a Python keyword, right? And it's also an operator for equality comparison, for checking for equality. So if we execute this piece of code, let's change the printout statement here. It's called is test, right? So here it's a equality operator test. Here is a is test, different printout, right? And then let's run it. So we got the printout from the equality test, right? Using the equality operator, but we didn't actually get the printout from using the is operator. Which means what? Which means this particular conditional test is never true
for all the numbers that's inside of the list, even when C actually has the value of 9 plus 12j. Right? Even when C has this particular value, this conditional test is still false. It's never going to return true. But why is that, right? Why is that? So if is also an operator that checks for equality, why it's never true, right? It's always false. So the equality operator, this double equal sign, compares the values on both sides. And this kind of behavior is also known as value equality. If the conditional test is true, then we have value equality. The is operator checks whether its left side and its right side actually point to the same object in memory. If the condition is true, then it is known as the so-called reference equality. So here the variable C on the left side, it's going to point to each element inside the list complex underscore numbers. But the right side here, 9 plus 12j, it's not really inside of the complex numbers list. It's not inside the list. It's a complex number literal or complex number constant. And Python actually allocates a different piece of memory for it. So this conditional test, which actually checks if the left side and the right side actually points to the same object in memory, is going to return false. So it's not going to check the value, it's going to check the memory address the two sides are pointing to. So if we really want this if operator, if this is operator to return true, how can we actually change this conditional test, right? Can we actually change this conditional test so that this is operator can return true? How do we actually change that, right? Can we do that? Let me still copy and paste this piece of code. So here the variable C will point to each element inside of the list, right? And when it actually points to the same memory address as complex numbers 2, complex numbers 2 means what? So this is 0, this is 1, and this is 2, right? So C is going to iterate through each of the elements in the list, right? So when C actually comes to this particular element, the variable C is going to point to the same memory address as this index operator, as what's returned by this index operator. So both sides of the is operator will actually point to the same object in memory. And in this case, the conditional test will actually return true. So let's change is test with complex numbers 2. Let's change it to like that. So equal test. And let's see what's going to be the result. Right, so we have this printout from this particular part of the code, this segment of the code. This segment of the code is not going to do any printout. And then here we have is test with complex numbers 2, ABS equals to 15. Now what will happen if we actually change the is operator here in this particular conditional test to the equality operator with the double equal sign? Right? What's going to happen? What's going to happen? Right. So what I was saying is that this double equal, this equality operator is going to compare values, right? And then the values inside of the variable c will certainly be identical to the value inside of the complex numbers too, because they are actually pointing to the same memory address. So this is also going to be evaluated, right? So this conditional will become true when c comes to this particular element, right? Yeah, that's indeed we were expecting, right? So double equal test with complex numbers too also gives you also evaluates to true. In the second video, we talked about the difference between shallow copy and deep copy. Now let's apply the is operator and the equality operator on those different types of copies. Right. So let's create a shallow copy of the complex number list first. Let's call it COST equals to just the complex numbers shallow copy. So add some comments here. This can be true, right? And then this can be false. This should be always false. And this can be true. And this can also be true. Right? So this is the shallow copy, right? And then let's do a deep copy. COST1 equals to. How do we actually make a deep copy? We can do that by using the slicing operator or the range operator inside of the square bracket. Right. So let's run this piece of code. We're going to have two more lists in our memory, COST and COST1. All of them have exactly the same content or elements inside of them. Right. So now let's print out the results of those comparisons. Let's use the is operator first. Let's do a print is test of shallow copy. COST, that's the shallow copy, is complex numbers. And let's see if that's true or false. Let's just evaluate. Is test of shallow copy, it's going to return true. And now you can understand why it's called a shallow copy, right? Because COST and complex numbers, these two lists are just basically different names pointing to exactly the same list in the memory, right? And then print is test of deep copy. COST1. So COST1 is the deep copy, is complex numbers. Right. Let's evaluate again. So is deep copy of is test of deep copy false. It's gonna return false, right? Deep copy means it's gonna allocate a new memory space and then copy over every element inside of the original list, right? So COST1 points to a different memory address from the complex numbers. Right, so this is evaluation. Also, so this is test. This is operator is going to return false. And now the equality operator. The equality operator of shallow copy. So equality test of shallow copy returns true. And this equality test means what? Equality test means it's going to check the value inside of the lists. It's going to compare the value of every element. And if they are identical, then it's going to return true. And you can imagine the deep copy will also return true. So the equality test of deep copy is also true, right? Because it's going to compare values. So the is test for the deep copy is going to return false because the deep copy allocates a new memory space with all the elements of the original list duplicated in the newly allocated memory space. So the deep copy and the original list are actually pointing at two different lists at two different memory addresses. So the is test is going to return false, right? But the equality tests using the double equal sign is going to return true for both the shallow copy and the deeper copy because those copies contain the same values. They contain exactly the same values, right? And the equality test with the double equal sign is it only cares about the values. It doesn't really care about how they are actually sort of allocated in memory. So if you have used Java before, the Python's behavior might be somehow the opposite of what you're expecting. In Java, the equality operator with the double equal sign is actually doing the memory address comparison. See if the two objects are actually pointing to, so if the two variables are actually pointing to the same object in the memory, right? And if you want to compare values in Java, you need to call the equals method on the object. But here in Python, it looks like it's just the opposite, right? Even though the Python doesn't have an equals object. For now, we haven't actually looked at the equals method in Python. And now let's look at equality comparison of strings. And Python's behavior may still surprise you depending upon your previous experiences. So let's create a list of strings first. Let's just use the countries. USA, Canada, Mexico, India. And we can loop through this list and use the equality operator to compare with the string literal, say USA. And if the condition is true, we print out the population of USA. So for country in countries, if country, we're using the equality operator, double equal sign, right? USA, and then we're going to print, this is double equal test, population, uh, 321 million. And if we run this code, we're going to see this line, test population 321 million. Right. That's what we are expecting. That's exactly what we are expecting. So this behavior is expected, right? Because it's doing a value comparison. So when country points to the 0th element of the country's list, the value in country, the string value in country is going to be identical to the string value of this string literal, the string constant, right? And in that case, this particular print statement are going to be sort of executed, right? That's what we're expecting. But now suppose we change the equality operator, the double equal sign, to the is operator. What's going to be your expectation, right? Suppose we change that. We copy this code over. And then we change this to is, and then change our printout. Then what's going to be the expected behavior, right? And when we did the is comparison between the variable c, this particular conditional here. When we did this comparison between the variable c, which points to a memory address inside the list, and the complex literal 9 plus 12j, the test returned false because they point to completely different objects at different memory addresses. Right? For this particular conditional test, country is a variable that's pointing to memory addresses inside of the country's list, and the string literal USA is it appears that it's not really inside of the list, right? So if we run this code, what exactly are you going to expect, right? Are you going to expect this line to be printed or not? In fact, this line is going to be printed, and this is test is going to return true when country points to the 0th element of the list. For this is comparison between the variable country, which points to a memory address inside of the country list, and the string literal USA, Python will actually return true, which means that they actually point to the same memory space. But why is that, right? Why is that? It looks like there's some kind of inconsistency in this conditional test and in this conditional test, right? So C is pointing to elements of that complex number list, and this is a literal, it's a complex number literal. But here, countries is pointing to elements inside of this countries list. But USA is a literal, is a string literal, right? So the only difference between these two conditionals is that here it's a string literal, but here it's a complex number literal, right? But why the behavior is like completely different? The reason is that the string is actually a very widely used data type, and in Python it is immutable. So what Python does is that it creates a separate memory space to store all the unique string literals that appear in our program. And this collection, this memory space used for storing unique string literals is sometimes called a string pool. So whenever we need to access a particular string that appears in the string pool, Python will give us the same string object inside of that string pool instead of recreating it in memory every time we ask for it. So this way Python can save a lot of memory. So here's the string literal USA that appears on the right side of the is operator is actually the same string object that appears at the 0th element of the countries list. So when Python actually sees all those string literals inside of the list, it has already created a string pool that contains all those string literals. And by the time Python actually sees this particular string literal that's used in the comparison here, it's just going to return the same string literal in the string pool that was constructed when it sees the countries list. So when the variable country, when the variable country points to the 0th element of the countries list, it is pointing to exactly the same string object in the string pool as this particular string literal. And that is why this is comparison actually returns true. And if we apply the is comparison, so if we apply the is comparison, between country and country 0, it will also return true. So this country variable, the country 0, and the string literal USA, they all point to exactly the same string object in the string pool. The string pooling only works for string literals. If we create two strings dynamically, it will not work. It's not going to work. So suppose we're going to print str5 is str5. So basically we are just here we're just creating two strings dynamically by converting the integer 5 to strings. So let's just run it. And it's actually returning false. It's actually returning false. Because the string 5 that's converted from the integer 5 is not stored inside of the string pool. So it is recreated in memory every time, and these two string objects are not pointing to are not actually the same object located at the same memory addresses. But if we do a value comparison, then it's going to return true, because the two strings that's constructed dynamically by using the str function indeed have the same value, have the same string value. So we will get a true. This string pooling technique is also known as the so-called string interning. String pooling or string interning. It is a technique for storing only one copy of each distinct string literal. It saves the memory spaces, but may increase the CPU overhead for creating and accessing strings. And it is also supported in Java and C#, if you have experiences with those two languages. And string pooling or interning is just one of the things that we must be sort of careful about when using strings in conditional tests. And if you have studied design patterns before, the kind of string pooling or string interning is actually an implementation of the so-called flyweight pattern. And in that flyweight pattern, what exactly is a flyweight, right? A flyweight is an object that minimizes memory usage by sharing as much data as possible with other sort of similar objects. So we must be careful. We must be careful when we compare strings in Python, right? There's this kind of behavior that might be unexpected if you are not aware of how Python handles those immutable strings and immutable string literals. And another thing that we need to be careful about is that Python is actually case sensitive. So when we compare strings, we must pay attention to the case of the characters inside of that string. So if we change the right side of the is operator from capital USA to small case USA, then both sides will not be pointing to the same string in the string pool. So case sensitive. So let's change this capital USA to small USA, right? Is test with small USA. And see, let's but it's not going to print. It's not going to have any kind of printout because this condition test is always going to be false because you have a case mismatch. Country is always pointing to these countries with the first letter capitalized, right? But here it's USA or small case, so it's a completely different thing. So this is going to return false. This is true, right? This is also true. and this is also true. I put the comment at the wrong location. Yeah. Yeah. Right. And we can also change this is operator to like a equality operator, right? And see if that's gonna make any difference. But it's not gonna make any difference. It's still gonna be false because the values are just different, right? So it's not gonna have a printout for this particular test, right? But in some situations, we do want to ignore the case, right? When comparing strings, for example, when processing certain text inputs from users. And a common technique for ignoring case is to actually convert both sides of the equality operator to lowercase, or to convert both sides to uppercase. So if we want to ignore the case, then we can do this thing. For country, in countries, country.lower, we convert the string inside of the country variable to lowercase by calling the lower method, right? So here we have converted the left side to lowercase by calling the lower method on the string object. The right side is already a small case, right? So there's no conversion needed. Right? And if we run this particular part, is test with USA ignore case, it's gonna print out no, it's we should do a value comparison, right? So is test with USA ignore case, then population 321 million. Right? This one is printed. Right? If I do not use this thing is, they are still going to point to different memory addresses. Small case USA is a different string literal with this capital case USA, right? So even though there might be a string literal of small case USA in the string pool, but the two string literals in the same string pool are going to be different. So they are still going to be inside of the different memory space, pointing to a different memory space. So here we have to do a value comparison, right? So this is going to be true. So once we have understood how Python checks for equality, it is not too difficult for us to understand how Python checks for inequality. Checking for inequality. So to check for inequality of values, we use the inequality operator, which is the exclamation mark followed by 1 equals I. So if we want to check for inequality, country not equal, so what's actually the current value inside the country variable, right? We have it here. It's India with a capital I, right? But here we are comparing it with India with a small case I. And this is the inequality for values. It's an inequality comparison for values. So here the variable country has the value capital I India with a capital I, right? And Python is case sensitive, so the string values are different on the two sides. And we are testing for inequality. So the conditional test should evaluate to true. That's indeed true, right? And then let's try another one. False. So in this particular print statement, the variable C, what's actually the value inside the C, right? It's a 12 plus 16J, right? So the value the variable C actually has the value 12 plus 16J, right? So both sides have the same value, but because we are testing for inequality, right? So the conditional test is going to return false. So that's indeed what's actually happening here. Right? That's the opposite of the value equality. What's going to be the opposite of the reference equality, right? What's actually the so the reference equality is evaluated using the is not operator. Right? In fact, let's look at some examples. Print. We have two copies, right? One shallow copy and one deep copy of the complex numbers list. If we don't exactly remember which one is which, so CLST is actually a shallow copy, and CLST1 is a deep copy, right? So let's check the deep copy first. CLST1 is not complex numbers. And then print CLST is not complex numbers. So in the first print statement, this print statement here, because CLST1 is actually a deep copy of the list complex underscore numbers, right? So they actually point to different objects in memory. They point to different objects. So this is not operator is going to evaluate to true. And in the second print statement, because the CLST is actually a shallow copy of the complex underscore numbers, so they actually point to exactly the same object in the same memory address. So this is not operator is going to evaluate to false. So again, so this is true, right? This is true, but this is false. And here, again, this is true, and this is false. And let's see if that's indeed the case. So true, false, right? True, false. So that's how you check for inequality. And sometimes we would like to take one set of actions when a conditional test returns true, and a different set of actions if the conditional test returns false. The if-else construct allows us to do that. So now let's talk about if-else statements. So let's still use the complex numbers as our example. But this time we're going to check the absolute value of C. And if it is smaller than or equal to 10, we're going to print modulus of C equals 2 plus strc plus is smaller than or equal to 10. I'll just do that. Let me give a period. Right. And then this time we're going to do an else colon print. We're going to do a different printout. Modulus of C equals 2 plus str plus is larger than 10. So the statement inside of the else block allow us to actually define a set of actions that are executed when the conditional test behind the if statement evaluates to false. So here we are testing whether the absolute value of a complex number is smaller than or equal to 10. If the conditional actually evaluates to true, then this statement, this print, is going to be executed. But if the conditional evaluates to false, then this print is going to be executed. And if we run it, so we're going to see for the first two complex numbers, the modulus is 5 and 10. So 5 and 10 satisfy this particular condition, right? 5 is smaller than 10 and 10 is equal to 10. So this conditional test for the first two elements in the complex numbers list is true, right? So it's going to carry out this print. So it's going to do this print part of the print. And the last two complex numbers have modulus that's 15 and 20, which is larger than 10, right? So this conditional evaluates to false, so it's going to execute this print statement, and then it's going to print out is larger than 10, is larger than 10, right? And if you are coming from other languages, you must pay attention to this colon here and then the indentation here, right? Python is not going to use those curly brackets like in C or Java to actually enclose different blocks of codes. It's using indentation to indicate the scope of a particular statement. So you have to be particularly careful about the indentation here, right? So if you don't indent correctly, then your code is not going to have the correct syntax. And another thing is that there's no AND statement. If you are sort of used to MATLAB, that kind of language, there's no AND keyword here, right? The AND is automatically indicated by the indentation of the lines or the codes below this block, right? So if the next line still has this kind of indentation, then it's gonna, if it still starts from this particular location, then it belongs to the else block. Otherwise, this code is gonna sort of start over again, right? So we need to pay attention to the colon and also the indentation in front of the statements. And sometimes we need to test for more than 2 possible situations. So if-else just allows you to test for like 2 possibilities. The conditional test is either true or false. If it's true, it's going to evaluate the block underneath the if statement. If it's false, it's going to evaluate the block that's underneath the else statement, right? But sometimes we need to test for more than 2 possible situations. And in such situations, we can use the so-called if-elif-else chain. If-elif-else chain. We must pay attention to the spelling here. It's not LCF, it's LF, right? LF is actually a Python keyword. So Python will start from the first conditional test in the chain and run each conditional test in order from top to bottom. And so as soon as one of the conditional tests returns true, Python will execute the actions inside of that if or elif statement and then exit the chain immediately. So the remaining conditional tests in the chain, if there are any, and their associated actions will not be evaluated at all. They are going to be completely ignored. All right. So now let's try to construct an example to demonstrate this if-elif-else chain. We will try to generate 30 random integers with value between 0 and 20. And then we will count the number of random integers with their values below 5, between 5 and 10, between 10 and 15, and above 15. So it's 4 ranges. We're going to count the number of random integers within those 4 different ranges. So in order to generate the random integers, we need to import the randint function from the random module. So let's go back to the top of the code. Here we're going to import from random import randint. In previous videos, we were mainly using some kind of sort of import collections, that kind of thing, right? Here it's a different way for importing. It's basically importing from the random module to import this randint function, because we are just going to use one function inside of that entire module, right? And then we need a list of counters to keep count of the number of random integers inside each of the range. And we are checking for 4 ranges. So in fact, we need exactly 4 counters. So we will construct a list of 4 zeros first. So count equals to 0 multiplied 4. So we have seen that the plus sign, this plus symbol, is overloaded for list for strings, right? If we use the plus symbol on 2 numbers, then it's going to do arithmetic addition. But if we use the plus sign for strings, then then we're actually doing string concatenation. So the plus sign is actually overloaded for different types of data. And here we are seeing that the multiplication sign is also overloaded, right? It's overloaded for lists. So if we multiply a list with a number, then the elements inside of that list is going to be duplicated this number of times. So if we want a list with 4 zeros, we can just multiply a list with 1 0 by 4. Right? Suppose let's run this piece of code, and then we're going to see the count. Right? It's a list with 4 elements and 4 zeros inside of it. And that's a quite convenient way for constructing lists. So now we can actually write a for loop to loop through all the 30 random integers with their values between 0 and 20. So for x, that's going to be our variable, in here we are using a list comprehension to construct a list of 30 random integers. So this for loop, this thing, looks like for loop inside of the square brackets. It's going to repeat like 30 times. It's going to repeat 30 times. So the rand_int, this rand_int function is going to be called 30 times. The rand_int function takes actually 2 inputs, which specifies the range of the value of the generated random integer. So here we want every call to the rand_int function to return a random integer with value between 0 and 20. And we do 30 calls. And now we can actually write the if-elif-else chain with the proper ordering of all the conditional tests and print out the value of the count. Just enter the loop. So if x is smaller than or equal to 5, count 0 plus equals to 1. If x smaller than or equal to 10, count 1 plus equal to 1. If x smaller than or equal to 15, count 2 plus equal to 1. And else count 3 plus equal to 1. Then just print count. So 7, 8, 4, 11. If we add those numbers up, it's supposed to be 30, right? 7 plus 8, that's like 15. 4 plus 11, that's 15. 15 plus 15, that's 30, right? So that's exactly 30. So 7 of those 30 numbers has a value smaller than or equal to 5. 8 of those numbers has a value that's larger than 5 but smaller than or equal to 10. And then 4 of those numbers has a value that's larger than 10 but below and or equal to 15. And then 11 of those numbers has a value that's larger than 15. Right? We must pay attention to the ordering of those conditional tests here. Right? If you are new to programming, this plus equal, this thing here, this operator here, plus equal, plus sign followed by 1 equal, which means that I want to increase the value by 1. So this kind of a operator is actually equivalent to count 0 equal to count 0 plus 1. So on the left-hand side of the assignment operator, we are retrieving the current value that's stored inside of the count 0, and then add 1 to it. And then the result of this addition is assigned back to count 0. And this equal sign, this 1 equal sign is the assignment operator. So if this conditional test returns, so here we test if x is smaller than or equal to 5 first. If this conditional is true, then we're going to increase count 0 by 1. Right? If this conditional test returns false, which means x is a value that's larger than 5, right? And then we check the second condition, which is x smaller than or equal to 10, right? Which is behind the elif keyword, right? And then also with the column that's behind it, and then there's the indentation for the block belongs to this particular branch, right? So suppose we switch, if we actually switch the ordering of these two branches, suppose, right? And then the logic will be wrong. Suppose x has a value of 0, for example, right? Which is certainly smaller than 5, but because this x smaller than 10, smaller than or equal to 10, appears first, and 0 is smaller than or equal to 10, so it's going to evaluate to true. So Python will exit the chain before even checking the second conditional, which is actually is also true. So this count 0 is not going to be increased, right? If we actually switch the order. So the ordering of the conditionals can be very important to determine whether your logic is actually correct or not. And in this particular example, we have two elif branches. In practice, it is actually possible to have more of those elif branches to cover more possibilities.